Okay, so today in our Going Digital series, we have a very young and accomplished speaker, Abhinav Singhal, who is an alumnus of IIT, BHU, and XLRI, and is currently working as the Chief Strategy Officer of Thyssen Group Asia. So he has considerable depth and experience in Industry 4.0 and specifically IoT, and that's going to be our topic for discussion today. So welcome to the Going Digital series, Abhinav, and thanks for your time.
Thank you, Siddharth. Thank you for inviting me. I'm really looking forward to the discussion today.
Great. So just to kick things off, Abhinav, from 2014 onwards, we saw that Gartner started talking about this IoT. They started saying that there will be some 20 billion connected devices by the year 2020.
Yeah.
Well, we are in 2020 now, so maybe you want to just start by telling us about where we are today in terms of Industry 4.0, IoT, what's happening in this market.
Yeah. No, I remember that. I remember that when Gartner came up with that number of 20 billion, we were all surprised by the sheer number when you reflect on that. And today, if you look at the current state, I think we have already surpassed that number. So now the new number which is floating around is actually 40 billion by 2025. And IDC has made this prediction. And this translates into, as per their estimation, around 80 zettabytes of data.
Wow.
And a zettabyte is like a trillion terabytes. So just imagine the scale and size of data which is expected to be generated, stored, and analyzed in the next 5 years. But I think these numbers don't make too much sense, honestly, as a business leader. What's interesting is to think about the underlying dynamics behind this growth. Why are so many devices getting connected? What does it mean for me? And I would like to highlight three aspects on why this has seen such a tremendous growth. The first aspect is the cost of sensors, which has drastically gone down. Because ultimately, to connect a device, you need to put a sensor on top of that. And if you think about 1980s, we were looking at a $20 cost of sensor on an average, which moved to $2 in early 2000s. And now you're talking about 30 to 40 cents.
Wow.
So when you have such a drastic decrease in cost of sensors, naturally, your ability to connect devices increases. The second element is then the storage and computing power, which has evolved. Because when you start putting sensors on devices and they generate data, you need to store this data and you need to process this data. So again, in the last 15, 20 years, as we all have seen with the rise of cloud computing, with the rise of GPUs and advanced processing systems, our ability to store this huge data and process this huge data has drastically gone up. And the last element is the AI and the machine learning bit of it, which is I've generated data, I've stored this data, but what do I do with it? I need to also analyze and get some meaningful insights for my business. And that's where machine learning has simulated how brain works today using neural networks and given us that power to work with this data in a meaningful manner. So these devices per se don't make any sense, but when you think about the drivers behind this number, I think we've made a lot of progress based on what Gartner projected, honestly, in the last 10 years.
Wonderful. That's a nice overview of what's happening in the market, Abhinav. If you have to explain this Industry 4.0, right, in layman terms, what would you say? I mean, what are the key technology and digital elements of Industry 4.0?
Sure. Now, I'm a big believer of simplicity. I think the easiest way to understand is Industry 4.0 gives us an ability to have real-time interaction between people and machines using data as a standard currency. So let me explain that a bit. What it means is that if I can connect data, people and machine together in real time, I can make connections between two machines. I can make connections between people. I can take output of a machine and share it with human beings to process. And likewise, I can take inputs of human beings and use machines to generate output. So I can now connect in real time mechanical and information and people processes. And that gives me the ability to do a lot of optimization in our business processes. So the essence of Industry 4.0 is how do you play with data? And if you look at all the technologies which we keep on hearing on a daily basis, I would say there are three categories of technology. The technologies which generate data and transmit it. There are technologies which store data. And then there are technologies which analyze data and you can act on a data basis on that. So when you think about generation of data, Internet of Things is one example where you can put sensors on machines and that can help you generate data and analyze it. Or it could be augmented reality, where again you're trying to simulate a physical environment into a virtual manner, and you can generate data out of that. And then you have your 5G and communication technologies, which help you transmit this data centrally for storage. Then, if you look at the second bucket of storing data, then you have cloud computing, which enables you to store huge amount of data. You have blockchain, which is another way of thinking about storing data and encrypting data. And then when it comes to analysis, then you have artificial intelligence. You also have some niche technologies around autonomous machines, which is an application of AI, or 3D printing, where again you're able to virtually do the engineering of a task and print it on demand. So for me to simplify for our listeners and viewers, think about Industry 4.0 as interaction of data, and each technology is playing some role in that value chain.
Wonderful. So, if I just try to drill down into what you spoke about. One aspect or one key element of Industry 4.0 is the ability to interact with the machines, pick up operating data from the machines, and then make sense of it. Derive trends from it, take predictive maintenance actions, and so on and so forth. I mean, it could be a million use cases for it. So, I want to understand how Industry 4.0, how does it change the game for the manufacturing industry, which already it utilizes a lot of automation, a lot of robotics, and so on. So what specifically does Industry 4.0 do for the manufacturing industry?
I think that's a great question, because a lot of time we get this question even from our customers, that we are possibly one of the most advanced in terms of automation. If you think about our manufacturing shop floor these days, we have been using robotics, we have PLC SCADA systems now. So what is new and fresh about Industry 4.0 in terms of automation? I would say the best way to think about is in three dimensions. I think Industry 4.0 offers for manufacturers first an ability to play with more quality and quantity of data, right? By that I mean, instead of just relying on a standard PLC output, I can also now have video data, I can have audio data, I can put sensors to capture information about my temperature, pressure, environmental conditions, and then analyze them together. So it gives me a lot more data sets to play with compared to what was possible with a traditional PLC or SCADA system. And likewise, I can store data for a longer period of time because now I have cloud. So I can look at the past 3 years, 5 years, 10 years of trend. Versus in a classical PLC system, you have very limited storage capacity possible. So one element of what is change and what is new is your ability to play with different and large data sets over a period of time, which means you can optimize much more.
Yeah.
Correct. The second element is the kind of algorithms and logic you can run on that data. So if you look at a typical PLC programmer, there is very limited kind of computation you can do with it. It's binary, flow diagrams, data sets. But now you can run, as we talked about, artificial intelligence algorithms on these data sets. And that also gives you a newer way of doing analysis and getting much more value out of the process. And the third element is our ability now to integrate machines and applications. So the convergence of IT and OT systems, as we commonly talk about it in a manufacturing context. So historically, I would have optimized for a ERP system, a supply chain application, a human capital application, and then a MES on a plant setup. But now I can integrate all of them together, right? And I can optimize the system instead of optimizing a specific unit or a specific function in the plant. So this, I think, is the tremendous power which you get now in terms of getting value out of your manufacturing process. The plant remains the same, the product remains the same, but the amount of productivity and efficiency you can drive by this optimization, by working with large data sets, by doing advanced computation on it, that creates the value for manufacturers.
Great. So, what opportunity does this create, for the IT industry? I mean, what kind of skills do you see that in the future an engineer will need? Want to tell me about that first? What opportunities it creates?
Sure. So I think it's again the convergence of IT industry with the manufacturing or industry or the operational machines. So I think both the parties, whether it is the IT industry or the manufacturing industry, need to now work closely together and need to know a bit more deeper of the domain of the other party. And by that I mean the IT industry needs to think of themselves as a partner in innovation, as a partner in the transformation of the manufacturing plant, and have a much deeper skin in the game, right? So if I've seen models where you have commercial arrangements on value sharing or productivity increase, and that's interesting for manufacturers because you're trying to help me optimize my business process, and you understand what is the value I'm creating here. Likewise, on the manufacturing side, because we talk so much about the need to play with data sets, I need my engineers to, apart from understanding the basic process of the plant, also understand a bit more about how is the data getting generated, what are the tools I can do for analyzing this data, what kind of applications can I use to visualize and automate the processes. So for manufacturing engineers, it is a bit more understanding of how does these technologies work and how can I best make use of this new raw material called data to drive productivity in my plant.
Excellent. So, if I go a little higher in the hierarchy, if I'm looking at a CXO or a CIO, what do they need to know about IoT or Industry 4.0 so that they can incorporate it in their initiatives?
So I think for CXOs, there will be two, three advices. I think the first advice would be think about what are the current business and operational challenges you are having in your plant or in your manufacturing sites, and then engage partners, engage vendors to get solutions for them. Because historically, we had some constraints as to what we can do in a plant context. But now, with the advent of technology, the degrees of freedom has increased, and there are a lot more ways you can solve problems than you would have in the past. To give you an example, for example, take a construction site. A common problem is how do we monitor time and cost compliance in a construction project, in an EPC project. Now I have a possibility that using drones, I can do real-time monitoring of the progress of construction. I can also simulate how much money I'm spending on each part of the module. And I can visualize in real time on 4 or 5 dimensions that how my project is scaling up, where are the bottlenecks, which part of the module I'm overspending, and visualize that. So likewise, in manufacturing, there are a lot more applications, a lot more use cases which have opened up. But for me, the value starts from business problem or challenge you need to address, and not by blind technology adoption. So that would be one key advice. The second would be about understanding the potential of these technologies and sensitizing the organization about them. Because as more and more technology adoption happens, there is a threat or a mindset that this will affect my jobs, my skill set. I'm going to become redundant, and technology and automation is against employment, which is not the right perspective. It's about automating few tasks and freeing up time of operators so that they can reskill themselves and do something which is more value added as a human being. So driving that change and addressing these mindsets of frontline operators is also really important. Otherwise, technology projects would never really succeed.
Great. I think that's a nice input, Abhinav. So, if you want to drill down a little bit more into the IoT aspect of this, and you want to share with us a couple of high value use cases, maybe from discrete manufacturing, maybe from process manufacturing, any use cases that would be useful to our viewers.
Sure. The value of IoT, as I said, is that you can put sensors on pretty much anything, generate data, and optimize. Right? To give you a sense, we looked at a chemical plant. Typically, if you store all the data which a chemical plant is generating, you're talking about roughly 500 terabytes of data in a year, right? All the way from inbound logistics, from product management or development to operations to supply chain and delivery to the end customer. So 500 terabytes of data gets generated in the process. And each part of this data you can then analyze, optimize, depending on what use case you want to drive. Right? To give you some examples of this. So let's start with logistics. When you think about inbound, outbound logistics, a very common use case is network optimization. What that means is you have a fleet of trucks which are arriving at your plant with your input material, with your supplies, you can put sensors on these trucks, and then you can optimize for fuel efficiency, for highest maintenance, for a particular route, for delivery time. So you can have a goal and objective, and then using the traffic data and using the way you're driving and which path you're taking, you can in real time optimize for that objective function. Another example in supply chain would be on warehousing. You can automate picking tasks, sorting tasks in a warehouse by using robotics, and that can help improve the safety and also the productivity of warehouse operators. Then, when you come to product development, a very common use case is digital twins, which basically is simulating a real physical object in a virtual manner. So, I try and put some sensors and recreate whatever is happening on my product. Also, I simulate that experience in a virtual simulated environment, and that helps me create MVPs. So in software we talk about MVP, that you create a minimal viable product and then you iterate on it. But in manufacturing you can do that by digital twins, because I've seen some car manufacturers who create digital twins of a basic model, and then based on the performance of the car they get live inputs, and then they come up with the next version of the product and then the next version. So it fastens your product development cycle. When it comes to operations, very common use cases are on energy efficiency. That is a very clear ROI. You put some sensors, monitor your energy consumption, and then based on the input parameters, you can optimize what is the right level of plant operate parameters I need to work with for maximum energy efficiency of that equipment. It could be a crusher, a grinder, or any object you're talking about. You have similar optimization for quality, for productivity or yield maximization. So in general, how do you maximize the OE or the availability of the plant? And finally, in terms of supply chain and customers, you can optimize for personalization, you can optimize for demand sensing. So I've seen in cement plant, for example, it's very difficult to predict what is my demand because I don't talk to my end customer. But using IoT and connecting data across the value chain, I can know whenever a bag of cement is being purchased by my customer, the distributor gets notified, the logistics or the warehouse operator gets notified, the plant gets notified, and then input query can also get notified. And in real time, you can plan for the next bag of cement, what all do I need to plan and keep. And that kind of power, you can only get when you think about the current Industry 4.0 technology.
I think these are great examples. Any example on the production shop floor itself, maintenance or actual production? Any example comes to mind?
So predictive maintenance is very common. So for example, we make cement plants, and we have seen for crushers and grinders that for some critical equipments or from you can monitor the wearing rate of one of the components of a crusher, and then you can have a model which tells you that depending on the size of limestone and the quality of let's say the raw material, what is the expected wear rate of the crusher lining, and before even it gets failed or it's due for replacement, you can predict that, and with 94% accuracy you can replace that. This helps you to minimize the downtime of maintenance of that equipment. It helps you to also plan your inventory accordingly, right? But there are many more. In fact, my personal experience is that wherever you touch, right, in a shop floor, there is an opportunity to optimize with the current technology set. So I think it's very contextual. Depending on your plant, you should start thinking about what are the main problems or challenges I have. I want to solve for EBIT maximization. I want to solve for availability. I want to solve for quality. And then there is enough options available today to actually try these tools and make that happen.
So, are there any concerns that a CXO should have, or an engineer on the field should have about 4.0, and what should they do about it?
I think I don't know if we'll call it concerns. I think the technology itself has a few limitations which the operators and CXOs need to be aware of. So when I talk about this grand scheme of data generation, collection, optimization, given the context today, I think there are also some challenges on interoperability of different machines. So how do you play with data across different OEMs, different machine providers? There are some challenges on cybersecurity. How do I protect the authenticity of the data? How do I ensure that my data is stored locally depending on the regulations? And also the cost itself, while it is drastically come down, still from economic perspective, only in few instances it would make sense. So I think there are some of these technology related concerns which you need to be aware of. that everything is not hunky dory, and a blind adoption is great to go ahead. On people side, I wouldn't call it a concern, but on people side, it has an implication. And the implication is, how do I reskill myself and first be aware of all the technology changes which are happening in my industry, and B, try and find new domains of knowledge, new kinds of skills and tasks where I can use my current, let's say, capabilities and redeploy myself, because I will have more time going forward. As some of my routine mechanical tasks are getting automated, I will have to find more meaningful tasks to do. And if I don't reskill myself, I don't retrain myself, then I have a risk that I don't have any meaningful jobs to carry on. But to give you some numbers, the prediction is that 50-60% of tasks in the next 15 years can get automated, but less than 10% of jobs will get eliminated, right? So the tasks are the stuff which you do as part of the job, and some of the manual tasks, repeatable tasks can get automated. But completes jobs in itself, which means that 100% of my jobs is just automatable tasks. They are still very, very less. And that's why I think the biggest implication is on reskilling yourself. In fact, my favorite line on this one is that artificial intelligence will not replace people, but people who can work with artificial intelligence will replace people who cannot.
Lovely. Abhinav, I think on that note, let's bring an end to this conversation. It's been very enlightening and very practical. Thank you so much for your time.
Thank you so much, Siddharth, for calling me. Really enjoyed it.
Thank you.